we get to kick off our seminar series for the semester with Haijun Xia. Oh, not bad. Good job. Haijun is an assistant professor at UC San Diego, where he is a member of their incredible design lab, as well as appointed in the Department of Cognitive Science and CSE. And I've admired Haijun's work for many years, I think going back to when we were both PhD students, because he's always sort of focused on tools for empowering people's creativity, but his approach to doing so, not only focuses on building really nice, polished, usable systems, but especially increasingly over the last few years, has been thinking more deeply by adopting sort of approaches from distributed cognition and cognitive science, and thinking about the representations that are at play in these systems. Another way of thinking about it is this work sort of points to the future of, say, user interface toolkits and conceptual models that are sort of much more analogous to old school HCI, which certainly has a fond place in my heart. So please join me in welcoming Haijun.
Thank you very much for the introduction. So, through my one-on-one conversation this morning, I realized people are really interested in our recent work about, human and AI collaboration. And I think I'm gonna cheat on that because I probably won't talk too much about that, but I want to talk about all the foundation work that led to those, recent work so that, when you check our latest work, you can see the connection there. So we have been doing a lot about redesigning information space, and we will talk about why. But I'm really excited to talk about why we need to look at this from the new lens of human AI collaboration. So just last month in the World Economic Forum, there was this panel, Generative AI, Steam Engine of the Fourth Industrial Revolution. And there was also this notion of AI is the new electricity, right? And I think, these analogies are really interesting and encourage us to think about how those transformative technologies were adopted in the, our world, and what are the changes we needed to make to fully leverage their potential. So if we go back to the first industrial revolution, which is driven by the steam engine, and around the time, each factory usually had this one massive steam engine. And, the power of the engine was distributed through all these rotating axles on the ceiling of the factory, right? And through these belts and pulleys, these rotating axles were able to drive the individual machines on the floor. And because the axles couldn't get too long, because otherwise the torque will break it at the end, right? So the machines must be clustered really close together with the one needed the most power closest to the power source, right? So the factory layout was designed to accommodate the power distribution system. And electricity drove the second industrial revolution. However, economists Erik Brynjolfsson and Andrew McAfee find that factory owners, they just bought the electric motors and stuck them where the steam engine used to be. They didn't change the factory layout. They didn't change the manufacturing workflow to leverage the potential of electricity. And for that reason, productivity didn't increase for almost 30 years. And only after new generations of factory designers or engineers redesign the layout, redesign the manufacturing workflow, and to leverage the flexibility of electricity, and then the productivity skyrocketed. So the new factory layout looked much similar to the modern factory, right? Actually, this is the color image. I intentionally turned it to black and white. And I think we're at a very similar paradigm shift of how information is manufactured and processed, right? Today, AI, this new power that drives the production of information, right? Images or text or 3D models. And very often we are hearing companies rushing to stick generative AI into their applications, right? And if history teaches us anything, probably we should think about, the information factory, our information space, and how that should be redesigned to support human AI collaboration. And more specifically, this application-centric information space, and examine whether that is a good foundation for our future. So what is, application-centric information space? So basically, we have millions of applications, each designed for a specific task with specific representation and specific tools, right? Photoshop is designed for editing images, and Excel is designed for analyzing data on the spreadsheet and then generate charts. And Premiere is about assembling materials on timeline to form a video. So we all know that these applications, despite the dominant interface we interact with the computer with, they are not the full picture of our activity, right? And in fact, these are just the tools to help us execute on really specific tasks, right? So here, many of your tasks, making a video about the Second World War or preparing a trip or, making a report involves, dozens of applications, right? And in fact, the process is not as clean as this clean hierarchical structure. It's even millions of miles away from this clean structure, right? And I want to use an example of making a video about the World War II to sort of remind us how complex a good piece of information can be and the complicated process behind it. So I will play this clip from the video, The Falling of World War II, and many of you probably have seen it as a masterpiece. So let's take a look. This one.
Here, we're just counting the deaths. And we'll begin with American soldiers. Over 400,000 died. Most of the deaths occurred in the European theater, fighting the Nazis. And about a quarter were in the Pacific, fighting the Japanese. When you put them on the timeline, you see that casualties were the heaviest at the end of the war. The war began on September 1st, 1939. But the US wasn't willing to join the fight until Pearl Harbor, 2 years in. The deaths increased drastically on D-Day, when the Allies invaded Normandy. One of the most tragic moments of the war was on D-Day at Omaha Beach, where 2,500 Americans fell.
So good luck producing something like that using AI today, right? And so I didn't know the exact workflow the creator used. All I know that he spent 2 years producing this, 20-minute long video, and with the software that he had to develop himself to produce this, right? But let's imagine we're trying to produce something like this, right? A video, and just think about the workflow we might run into, right? We probably need to have, computation notebook or a spreadsheet to gather data insights, right? And we probably need to have a document to write up the narrative, right? Plan the different stories, and probably need to sketch the visualization to sort of like test it out, or, probably using D3 to create a really customized visualization. And there was images, and you probably need Photoshop. And there were also like really cool animations, and you need to use After Effects. And also the sound effects in that piece, right, was amazing. And you probably need some of these audio editing softwares. And we can't just put everything together and call it done, right? There's a lot of coordination of these different pieces of information, and we need to balance their interdependencies, to produce something that is really coherent. And if you want to change a little bit of your story, imagine you want to just tweak a little bit of the data or the which fact you want to report, or the story, or in the ways that you need to report it. You need to rework your script, reproduce your voiceover, remake your visualization, readjust the timing, realign everything, right? So there is rich connections among these things, and every small change will turn into these cascading effects through the connections. And sure, adding AI to each individual application can probably make things easier for each individual piece, but it's far from enough, right? And I would argue that there are two things it lacks. First, it leaves the really complicated coordination of information to the user, right? I have to balance all these things and manage all these things. And second, I would argue that the application-centric AI is not going to produce the content you really need. Because when we are making every edit in all those software, sure, it will be tedious and slow, but every edit is informed by the whole context of the activity that we have in our mind. Whereas application, even though it can automate some part, it doesn't have access to all the whole story, right? And imagine without having access to what your story is about, having the best creator in the world, they probably won't produce the content you need, right? They probably, won't satisfy your constraints and needs. So I think if we want to make AI useful, we need to break these silos, right? And let AI use relevant information as the context to create the content you want. But even that is not enough, right? I don't think we will ever take the first MP4 file, spit out by whatever model, and call it done, right? And that is because most of the time when we are dealing with really complicated information activity, our understanding of that activity and our context and our goals evolve over time, right? We have shifting, these really dynamic goals and dynamic process. And during those iterations, I want AI to tell me like what's the context it's based upon, right? I want to know the steps it takes to get there. And when creating a video, I want to know the narrative structure AI generates. And I want to know the sources of information it pulls from. And I want to know how certain informations are organized together in certain ways, right? And right now, we don't have anything like that. So, in our lab, we conceptualize the information space as two layers, right? There's this information layer that instead of seeing information as materials siloed within individual applications, we see them as entities that can be directly accessed and flexibly associated with each other. So we see information entities as these entities that consist of their representation, their content, the context it can preserve, and the behaviors that they can exhibit. And in our lab, we explore some of these behaviors. They're not all the behaviors that are possible, but we explore the transformable representations and semantic association that allow you to compose information together, and also context-aware behaviors. And also at the activity level, we have explored activity-specific structures as scaffoldings for users' workflow. And we haven't done much work here about using this scaffolding for human AI collaboration. But I hope at the end of the talk, we can see the value of using this potential scaffolding as the interface between human and AI. So let's begin with the information layer. So very often when we think about information or information entities, we think about images, we think about videos, we think about charts, right? These are quite complex information entity. So in my early work, I went to explore the smallest entity we can interact with. And because that will allow us to explore how complex entities can be built using these building blocks and generate more complex information, right? And also how information can be freely combined and disassembled to really enable this modular kind of design. So what could be the smallest information entity? Maybe a number, right? But a number is meaningless if you don't give it a context, right? They can be a variable in your program, or they can be a property of the graphics you're editing. So in my PhD, I looked at attributes in graphical user interface and explore whether we can see these attributes as information entities and what we can do with them and what kind of complex information we can create with these attributes. So I built a system called object-oriented drawing. In this system, attributes are not numbers, are not text. They are objects you can touch and interact, right? So each drawing object contains these different attribute objects that defines this object. And you can tap on one of them to see the sub-attributes. And if you don't want an attribute, you can just remove it from the object or add it back, if you want the effect back. Or you can add, in this case, a drop shadow to this object. So now with attribute represented as entities, let's take a look at some complicated graphical object we can compose. So here I can compose attributes as templates. Here using a star geometry and color and Gaussian blur, I can create a star template. I can also create interpolation object. So here I'm trying to interpolate between these two color objects. And I'm dragging the color. I can color the waves on the canvas. And I think one of my favorite feature in this project is, once you see information as entity, each entity has the ability to preserve its own history. So here I'm making a few changes of the fill color, right? And later I switch my attention to the stroke, but then I realize the previous fill color worked best. And I can just open the fill color entity, right? And then go back to a previous version of the fill color. Like in today's environment, these undo and redo ability is at application level, right? But our point is to separate information out from the application, right? So the information itself preserve its own history. So here, we explore a different scenario of how attributes can be used as selection rules. So here I'm trying to select all the red petals in the top Easter egg. And I can just grab the color and say, select by this color. But then you notice all the two other objects with the same color also selected, right? So, if I want to constrain my selection, what I can do is I can say, borrow the shape of the Easter egg and compose a more complicated selection rules. And the selection is, constrained to that set of objects. I can make the edits. And if I want to shift my focus, I can, sort of like invert the boundary and select the other objects. But nobody will make selections like this, right? You're selecting by rules. Very often people just go in and select one by one, right? So here I'm selecting all the stars on the canvas. And as I'm doing the selection, the system analyzes what are the common attributes yours, among them, and recommend these attributes for you. So here I'm really selecting the star using the geometry. We have also explored combined visual attributes with data attributes as visual encodings. So this was actually inspired by a project called the Editor project, where two artists, they somehow decided to draw personal visualization about their event, on a postcard. And they, create postcard every week and they mail postcard to each other every week for a whole year. So at the end, they have all, these 100 postcards that are permanently collected by MoMA, and they documented, their process as a book. So if you look at these postcards, the front shows the visualization, right? So this is the week of shall I moment, like whether, the moments of making hard decisions. So each lollipop represents an event, and the length of the stick represents how much time they spend on making that decision. And I also thought, this is really interesting, and I wonder how can we create something like this easily? And turns out, creating visualization is really just creating visual encodings, right? You're using visual attributes to encode data attributes. So what I'm going to show you is a system called Data Inc. And in this canvas, I'm going to visualize a data set of the dogs I have seen in the past week. You can imagine a CSV file already loaded, and each row of the CSV is a dog I've seen, their color, their leash color, and things like that. So what I can do is I can draw a dog and tell the system that I want to use this as a template to populate all the data points. And now if I tap on each dog, I see the data properties of this data point, right? So these are on the outer rings of that. And if I want to create visual encodings, I can select the shape to call out its visual attributes. So here, if I'm changing the fill color, everything will be changing because everything is data driven, right? But I want to create encodings. So I want to use the fill color of this shape to encode a data attribute, right? So I just combine them as a visual encoding. And I can apply, new color, and that will only apply to object of that particular data attribute value. So next, I want to, represent the leash color, right? So here I'm drawing a leash. I actually don't know where I draw it there. I should really draw at the bottom of the head. So I can select that shape, make the encoding, right? Use the color to encode leash color. But here I made a wrong encoding, right? So I can just separate them and make a new encoding and adjust the color, right? So here you have this two ring of UI. The inner ring is the visual attributes of the object, and the outer ring is the data attributes of the object, right? So by combining these attributes together, you're basically configuring the visual encoding. So I want to show you another example that my collaborator made. She was in Seattle, so she wanted to use raindrops to represent the sad moments she had during a week. And here the color, the shade of blue, the size, the different groups all represent different kinds of information. Here's another example of how many thank you have received or given in the past week. And each card is a thank you moment, right? And you can see there are two people in a card, and that's, one of them is you and the other person is, the other party. And there are different colors because there are different groups of people. And later you will realize the person on the left in each card is replaced as a phone or as a laptop that represent, where that thank you happened, whether that happened on a phone call or during, chat on, a laptop, right? Imagine we are all researchers here, right? Imagine you are trying to create a visualization of the paper you have published, right? How many authors on that paper, whether that have received a word or the citation number, all these can be encoded really easily, using this system. So I hope this gives you guys a sense of how we see information entities, right? Having these really composable entities enable organic generation of more complex information. And somewhere you probably seen this, like, entity can preserve a little bit of history or context, right? And I think this context, aware behavior is super interesting. And I did another project recently to explore it further. But I want to do a brief show of hand here. We all used Zoom for a while during the pandemic. Raise your hand if this ever happened to you, right? You are on a Zoom, you want to share something interesting, but it's taking a very long time to find it and to find to the exact point you want to share it, and you got anxious, you are feeling, you're wasting everybody's time. All right, we have some Zoom masters here. So, that's exactly the scenario that's highlighted here, right? I shared a PDF file with, some of my students, and I'm trying to find the quote in this computer for the 21st century, like technology disappear into the background, but I couldn't find it, right? So I took a long time to scroll it. But, what's really happening is, as I'm sharing this file, I'm talking about this thing. I'm talking about, there is an amazing quote in this paper, where technology disappeared into the background. And what it does is this PDF entity listens to that conversation and recommend relevant content on the sidebar. And those are navigation shortcuts that take you directly to the paragraph that, talk about that particular content. So the reason we can do that is because we see them as information entities. Everything you share in this environment is an information entity that contains three components, right? The content of the entity and the context and actions it can take, right? For a PDF file, there's main content, metadata, and there is also the context, who shared it, what are the conversations we had on this entity, and some of the actions this entity can do, right? Navigation or content search. And we describe all these using natural language, right? Including the actions they can do. So for example, here, navigation, there's a description of navigating to the view of the mentioned content. And the reason we do that is once you take these information entities in the environment, you can take the conversation as input. And in real time, you can find the most relevant content or context or action that is within each information entity. And you can ask that entity to trigger that action or to highlight the content and give a recommendation to the user. The user can decide whether they can take it or they want to accept or not. And that operation is a history that will be recorded as context. And the point here is that these intelligent behaviors are specified at the entity level. They're not specified at the environment level, right? I can throw an information entity into that environment. I don't need the permission of this application to register my, to give me the intelligent behavior, right? These intelligent behaviors are within each information entity. So here's another example. Here a person is doing a screen sharing of their presentation. So in this system, screen sharing is persistent instead of transient. Means when you stop your screen sharing, everything was recorded during your screen sharing, but it's recorded on your local side. And if you're done with your screen sharing and say, actually, I want to make it public so that everybody can look at it and then, talk about it later, you can sort of like drag this material from your private space to this public space. And that is shared among people. And if other people said, actually, I have comments for the motivation section of your talk, they can just sort of like, mention that. And the video entity will listen to this conversation and recommend relative like time step on the timeline, right? You can go to the time step or, drag a, that particular frame out as a, maybe canvas or image so that you can annotate on top of it to, further the discussion. So this is sort of like, hopefully you get the idea of, by promoting these information as entities, by allow them to preserve context, we can, create some really interesting context-aware behaviors without a really complicated, environment. So I think, one thing that was kind of indicated is that, by choosing a good representation, you can enable some interesting interactions with the information. Like by turning attributes as objects, you can interact with them, like objects. But representation also limit, your interaction with the information, right? In this case, imagine you're designing a note-taking application. There are different representations we can take. You can take a pixel representation of the drawing, and that's basically a drawing application. right? Or most note-taking applications use the stroke level representation. Or if you use Notion, right? Everything is text and really clean. So most of today's applications use one representation, but that means giving up all the benefits of the others, right? So picking the stroke level representation means I'm giving up the precision because of the pixel representation, or I'm giving up the tidiness of the list representation, right? So, but why do we need to sacrifice? Or can we escape the design pattern where applications use single representation for specific task and enable information to fluidly transform from one representation to another? So I built a system called ReLarge. It's a digital whiteboard application running on a large display. So you can do some really simple things like recognize a piece of text and unrecognize it. But what's really happening under the surface is you are transforming the content along different representational axes. So let me just show you one example. So I'm drawing a table, and to be able to draw a table is really nice. You can define the columns, rows, the number of those, and the width and height. So by default, I'm at the stroke level. But if I want to do some digital computation, I can push the system, say, turn this into a table representation because I want to put numbers in. But at this table level, I realize the last column is too wide, right? I want to divide it. So I can draw the stroke, but it's interpreted at the table level. So it's recognized as gesture to split a column. But let's say I want to merge all the cells on the top row. So what do? Do I do another line? But that will split the rows, right? So for me, if I'm like, if this table is drawn on a whiteboard, I can just erase the parts that I don't need, right? So with the system, what you can do is you can bring this table down to the pixel level, and you can erase the parts you don't need. And you can push them level back to the stroke level, and then one level up to the table level, right? So I'm not saying this is the way to merge all the cells on top of it. I'm just saying, that's what came to my mind as a user, right? I think, today, when we're developing applications, we're constraining the user in terms of the representation they can work with. But I think we should really think about the representations we can provide so the user can use different representation to reason about a task. And I think that's super interesting for AI, and that's the slide for you, Angie, is, instead of using these, actions provided by the application, can AI transform the information to the representation that's easy to reason with, and then transforming the information back, right? I think a lot of creative thinking is about transforming the representation of the information and work with that representation. And it would be super cool if AI can pull that off. So we have other examples of these changing representations. So this is the holy cow, and it's at the picture level. So what you can do is you can draw on this picture and leave mark. That's a very natural behavior, right? But you can turn this pixel to a picture to pixel level, and then you can directly interacting with the pixel. So here, push it down to pixel level, I can directly interact with the pixels on the canvas. Or here, my pen is no longer a pen drawing on a picture, but it's a selection of tool that allow me to select the pixels to keep. So my student Pei-Ling really took the idea of this like transformable representation and find the information that he was dealing with every day is not using the best representation. So he was doing web development, and then he needs to look at all these log messages in the console. But it's just this log message is really a linear stream of text, right? And imagine you are trying to look at different values outputted, using these log statement. You have to open all these objects one by one, and then look at the values, right? Or you have to sort of change your log statement, but then you got these numbers. But these numbers are also not helpful. If I want to see how they change over time, I can benefit from a chart maybe, right? So he developed a system called Logit. What Logit does is, because all these statements are output by the same statements, so their interaction are synchronized with each other. And if I want to, only show the value, variable in this JSON object, I can just double click on it, and then I can see these values. Of course, these numbers are not useful. So what we can do is you can create an alternative representation of these, turning them into a chart so that you can easily see it change over time. Another really neat feature is, unlike the traditional log console, that everything from everywhere is organized into one global linear stack, left aligned, right? What we can do is, because these entities are printed out by different log statements, and they have their place in the program, and that place is actually really important context for the programmer, right? So here, these two log have different indentations. So what I can do with these, log messages is I can bring these indication back to the state, print out messages, or I can, apply that idea to log statements from different files, different processes, different packages, right, to allow me to easily, find the group of log messages I need. So another scenario we apply this to is Grapholog. Finally, we're talking about a large language model project. So, and if really take this perspective of transformable representation, it will be very obvious when you chat with GPT, you will realize this is not a good representation for your task, right? Imagine I'm trying to understand what earthquake is. This is really a lot of text, right? I'm trying to understand the key concept of earthquake and their connections. But all these really interesting entities, or concepts or relationships are buried within the text. So we can benefit from something like a diagram, right? So that's sort of our goal. It's a really simple goal. Can we take the text from GPT and generate a no-link diagram so that we can facilitate like concept understanding? So we built our first prototype, which is, basically the prototype will take all the text printed out, received from GPT and do some interesting processing, extract all entities, and then plot them as diagram. What do you think about this diagram, though? It's really bad, right? That is also not a good representation because this diagram is also really, really complex and it's really hard to understand. And one thing that we find that's really interesting is if you provide the diagram after the user has already received the entire text, seeing the new diagram is really jarring because when you're reading the text returned by GPT, you're forming a mental picture. You're piecing the information together somehow, maybe as another diagram, and seeing a totally different diagram is just really hard transition. So our design goal is, we want to use the diagram as a point of entry, but we want to receive it at the very, very beginning, right? How is that even possible? So I want to show you what we build. This is the final system. You type in a query, and the diagram are generating on the fly in real time, the same time as the tokens, that are received from GPT. So here you can see, we're filling in the different nodes and generate new nodes as the information is coming in, and then build new connections among these concepts. So how did we actually, get, the diagram generating at the very, very beginning? So there are only two words that is the secret. We call it inline annotation. So we basically tell GPT, like, as you are generating these responses, annotate inline of the roles of these entities, whether they are a non or a relationship word, and just give me all those annotation, right? So this is actually what we receive, from GPT. And, we can parse these, different sort of like annotations and turn them into a diagram. So let's take a look at this again, but this time I want you to focus on the left part of the interface. I'm gonna turn on the annotation. So you see here, these are streamed in real time as, the tokens. And we can sort of like basically, create new nodes as we see a bracket and then close the node or finish the node as we see the end of the bracket. So, but once you have the diagram, you can use that as an interface to work with GPT, right? If you are unclear about a particular concept, you can say, can you explain this? Or can you give me an example? And that will basically extend the chart with a new subgraph, right? That allow you to, see these concepts and how they connect. And you may think, what if we can just leave the text, right? We just look at the diagram. Maybe that's enough, right? And what we learn is that one representation is usually not enough. Just seeing the diagram, it's nice, but sometimes you really want to see the original text where the information is embedded in to get the full information, right? The full context. So it's really important to establish these linkage between the raw text and the nodes. So here in the system, when you hover on the node, the text in the raw text is highlighted, or vice versa, right? So here, basically when you hover your mouse cursor on the text, the nodes will be highlighted. So I think, this gives you an idea of what do we mean by transformable representation, right? It really opens new sort of interaction space for human and AI. And also, like my colleague Jim Holland used to say, if something is worth representing, it's probably worth representing in different ways because there are different contexts you may want to use. You may have different goals, right, with that piece of information. So let's move up to the activity layer and take a look at what kind of structure we can create to really organize all these different kinds of information entities and structure our workflow. So my student Rima was very interested in this type of data storytelling content, which use really compelling narrative and rich visualizations to tell a story. So this story tells us like how women's gene pockets are, how less functional they are compared to men's. And this one is a story about shark species that are endangered due to human activities, like mostly industrial fishing. And you look at these different kind of stories, what you find is that despite the different layouts and animation and the style, they use this very common one-to-one mapping structure. Basically, you have a piece of text, and that is mapped to a particular visualization or a change in that visualization. And if you look at their planning stage, they're using very similar structure too, right? They will use Google Doc to have a table of 2 columns. In the first column, they write the story. The second column, they write a description of the visual they want. But the in-between process is really, really messy, right? It's very similar to the video making process. So for us, we're like, why don't we just maintain that structure? If that's a desired structure, why don't we maintain the connections between text, between viz, and all the effects we want to apply, and maybe a little bit piece of code you want to write on that visualization. So we developed a system called Data Particle, and she demonstrated the system using a story about her trip to CHI 2023. The events that she went to, the talks, the social events, and stuff. So when you load the data into the system will create the first block for you, which basically visualize all the data points for you to start with. And you can make a new block. And on the left side of the block, you can write the story you want to tell. And as you are writing, the system is analyzing your text, right? It's trying to find, which data you are trying to, talk about, and what's the property, like what's the, type of this data? Is it continuous or is it categorical? And what's the data operation you want to do on this? And what are the visual encodings you want to apply, right? So all that is handled by, a little engine we have at the back end. And so here, different activities are, encoded with different colors. And next, she wants to talk about the time that she spent on different activities, because time is a continuous variable. So that's encoded using this, continuous radius of the circles. But, she's like, I kind of want to, shuffle the story a little bit. I want to talk about the time I spend and then talk about the activity later. She can shuffle these blocks. And that will kind of create a problem here because the visualization no longer makes sense, right? If you look at the time block, we haven't introduced the activities yet, right? But the activities are colored already, and the activity now is here. So what we can do is we can, have this manual operation where we propagate the data from the previous block, apply the new encoding, and sort of like gradually apply these effects. And you may wonder, why don't we automatically change everything? Change all the styles to fit the text, the new structure. So what we find is that when you do an automatic change, sometimes if you have a really long story, your whole visualization just all of a sudden, change dramatically. And there's no way to understand what's going on, right? So we left that part as a manual operation from the user so they can, progress from the beginning and see whether things still make sense. And the right part of the canvas or this middle part of the canvas allow you to, customize different, the visualization, right? Have a different style. So again, right, the point here is we're not dealing with individual information or application, right? We're doing these activity level information management. And you can imagine images can be added there. And if you are unhappy with a particular image in a particular blog, right, you can maybe get into that image and use some of the tools or AI to help you with that editing of the information. But you're not dealing with all these information on the side and at the end try to put everything together. So another case study we did is, an extension of the system, but for video planning and editing, right? Probably you still remember the crazy workflow for making that video we showed at the beginning. But turns out you can untangle that crazy process into 4 different stages of video making activity. You are collecting your assets at the beginning, then you develop a narrative, then you use this kind of table, some people use Notion, this grid structure to help you organize different pieces of information together. And at the end, you put everything onto a timeline. So if you look at these different stages, you use different information structure, right? But right now, these structures are constrained within different applications. And you have to manually move information from one to the other. And a lot of times these connections are not maintained. You have to manually maintain them. So what we propose is what we call transformable structure for video editing and video planning and editing. Basically, we put all these structures together, and what you can do is you can drop any piece of information in anywhere you want, right? You can put in the grid, structure directly, but that information is synchronized to the canvas view to put together with the closest information. Or you can put information into the canvas view, and the right pieces of information is taken out and recommended to a spot in the grid view. Right? And then there is this tight synchronization between the grid view and timeline, right? You can automatically generate a video from the grid view and then do some fine time adjustment using the timeline. So, this is sort of the structure I want to use with, every day when I'm making video. But also I want AI to use this structure, right? I want AI to give me these overview of what are the sources of information it's using in the canvas view. I want the AI to tell me the steps that it take to create the different information a different structure and how these structures are connected. And because with that, I can choose to accept it, or I can do fine tune of the images, shuffle a few things around, or tear it apart and create a new structure, right? So I hope I convince you that this structure will be useful even we have an AI that to help us scaffold the communication between ourselves and AI. So these activities really help us manage all these activity relevant information and serve as the common ground between us and AI. And maybe let me just sum up here. So at the information layer, right, we talk about we want organic generation of complex information. We talk about these entity level contexts that can enable really interesting behaviors. And we talk about these transformable representation that can enable new interaction space. And we also talk about these activities that can, activity structure that can help us scaffold our collaboration with AI. So we need 2 layers, right? An activity layer that provides a structure, allow human and AI to remain aligned in the process of collaboration. And we need this fluid information layer that enable both human and AI to fluidly access relevant information and assemble and transform the information. So I think, working as a whole, this is the sort of new layout of our information space, right? It's different from application-centric space. I'm not sure whether that's the best one, but I think we probably should think about something that's different from the application space. And maybe with that, we can really realize the full potential of AI. And that's it for my talk. Thank you.